Hello, today we are going to be discussing rocks. My name is Keller Johnson. I love rocks. So, the first rock we're going to be talking about is coal. Coal is a very distinct rock and a pretty easy one to identify. It is black. It is very brittle. It's also just so noticeable. When you see coal, you know it's coal. When you pick it up, it's a very light rock. And, despite its size, you wouldn't think it would be so light, but it is. It's a very light rock, easy to identify and spot. When you hold it up to the light, you generally see light reflecting off of it. It is a sedimentary rock that has been made up of plant fragments. That's just coal. I like coal because when I was younger, we had like a little coal deposit in our yard, and I would dig holes and ton of coal. So, I love coal. Coal's a very fun rock, and one of the first rocks I ever knew. The next rock we're going to be discussing today is a conglomerate. A conglomerate is a sedimentary rock that is poorly sorted and formed in a high energy environment. Conglomerate basically means it's a conglomeration of other rocks. So all these other different rocks came together and they're now inside this conglomerate. So it's one rock, but it's made up of a bunch of other ones. Generally, these rocks have quartz and things like that in them. The conglomerate, generally, the rocks inside conglomerate are rounded, and you can see, kind of the rounded surface on all these other rocks inside the conglomerate. That's a good way to distinguish it from breccia, which is another sedimentary rock. Breccia has pointy edges, and the rocks are more flat. Fun facts about conglomerate. The next rock we're going to be discussing today is muscovite. Muscovite and biotite were some of my favorite rocks to learn about this year. They are both flat. They have cleavage in one plane, which, basically means that they are a flat rock. They are both minerals. One of my favorite things in class was when we were identifying them, I accidentally broke one. It's just so thin, so brittle, and I broke it. I felt bad at first, but it was kind of fun. It's just so satisfying. But good ways to identify those is they are black, one's white, whitish clear, and they have cleavage in one plane. So you could have a sheet, like literally you could have massive sheets of it that just pull apart in sheets and sheets, kind of like a box of copier paper. I mean, that's literally what it is. The next rock we're going to be discussing today is scoria. Scoria is a very fun rock. This is one of the other rocks that I was first able to identify. Scoria and pumice. They are extrusive igneous rocks. They formed from lava. The gas, when the volcano erupts, the lava's on the surface. And generally when gas is under that lava, it comes up through the lava, producing all these holes and air bubbles. That is how scoria and pumice are found. They are considered vesicular. While most igneous rocks, go from mafic, ultramafic, and felsic, these are considered vesicular. That's how you identify these rocks. The other fun fact, igneous rock that does not go under the mafic, felsic, and ultramafic category is obsidian. Obsidian is glassy. That is just such a cool one to look at. It has such a odd, weird fracture and breakage. It always reminded me of like thick glass. Like when I was younger, I would break. I loved breaking glass. It's kind of stupid, but when you break a thick piece of glass, that's what obsidian looks like. So that is a very glassy rock and another cool extrusive rock. The next rock we're going to be discussing today is, diorite. I love diorite, mainly because I love Minecraft, and I would always mine diorite. It was the coolest rock to build anything out of, mainly because it was white, black, and had some kind of clear sections in it. It is a very strong rock, it's used very useful for building. It is a phaneritic intrusive rock, which basically means, it's got a ton of different like crystals and minerals in it, and they're all about the same size. So that's just some fun facts about diorite. Diorite is an intrusive igneous rock. The reason it has all the crystals is because it's been inside the volcano for so long that it has had time to form all these crystals. It basically cooled slowly. The reason these other extrusive rocks that we've previously discussed, like obsidian, scoria, and pumice, don't have crystals is because they cooled fast. With the fast cooling, they did not have enough time to form minerals. The other intrusive rocks that do have crystals, excuse me, I meant crystals a second ago. Scoria, pumice, and obsidian did not have time to form crystals. But these other rocks, granite, diorite, gabbro, and andesite, all are intrusive rocks that have cooled slowly from magma and lava, and that is what forms the crystals. They are under a lot of heat and a lot of pressure. Those are very fun rocks. A good way to distinguish granite from diorite is the pink. Generally, granite will have pink. The pink comes from potassium feldspar. Potassium feldspar is a very cool rock that helped me identify a lot when I was taking geology at Virginia Tech. It's it's just a good way to tell granite from diorite. Another rock from the volcano that has a lot of potassium feldspar in it is rhyolite. Rhyolite is an extrusive igneous rock. It is generally pink. It's like pretty much a solid color. It generally does not have crystals in it. It's a good way to think about igneous rocks. We love igneous rocks. The next rock I'm going to be talking about today is gneiss. Gneiss is a metamorphic rock. That's always been an interesting one for me to learn about. The stages for gneiss was slate, phyllite, schist, and then gneiss. These are all have a banded texture, which means there's just layers in the rock. You can see the layers. So the first one I said was slate. I always remembered slate because that's what they used to make pool tables out of. Like a pool table is going to have a sheet of slate. That's because they're so flat, and it makes for a nice flat even surface, to play pool on. Excuse me. That's how I always remembered slate. Phyllite, that's just one I kind of had to memorize. That was a pretty tricky rock for me, but it does have a very distinct look. And then schist. I loved schist. Schist had garnets in it. Garnets are one of my favorite gemstones. That's my girlfriend's birthstone, so I've bought a lot of garnets. But they're really cool. They're really pretty rocks. They're red crystals. So that's a good way to distinguish that rock and be able to point it out. Schist has a lot of garnets in it. But gneiss is basically the last step in the formation of these rocks. Gneiss, it's a metamorphic rock and it's coarse grains. Gneiss, it's literally just layers, usually generally white and black, but it's a very, very fun rock to look at, and I've always wanted to find one out in nature. That's always been one of the rocks that I'm I want to see that somewhere and spot it and just be able to identify it. So that's gneiss. The next rock we're going to be talking about is calcite. Calcite has, as you can guess, calcium in it, and calcium reacts with HCl. So that was a very easy way to distinguish that rock. At first, I thought it was halite, which is the salty rock, so I licked it. It did not taste like anything. Halite, when you lick it, tastes like salt. I licked a lot of rocks in class, and people always Keller, what are you doing? And I'm taking my test, learning my rocks. But this rock reacts with HCl. And that's just a very easy way to identify it. There are several other rocks that also react with HCl because of the calcium in them. Calcite usually has cleavage in two directions, and it is a non-metallic, light-colored luster. Interesting rock. The next rock we're going to learn about today is quartzite. Quartzite is non-foliated metamorphic rock. Non-foliated, I believe, means it doesn't have the layers. So it's in the same category as the gneiss, phyllite, schist, and slate. The parent rock for this is sandstone. The other metamorphic rock is marble. The parent rock for marble is limestone. You know what limestone has in it? Calcium. That reacts with HCl. So a good way to tell marble is the HCl. And that's marble and quartzite, those other two metamorphic rocks. The next rock we're going to be talking about today is rhyolite. We already talked about this some, so this will be a quick one. Rhyolite it's extrusive, and it's an igneous rock. It is very easy to tell because of the pinkish tint from the potassium feldspar. Fun, fun, fun. The next rock on our list today is olivine. Olivine, literally hands down, just I see it, I know it is. Like, it's green. Like, no other rock we went over was like this green. It's a mineral. It's a very pretty stone. It's used in jewelry a lot. Just a cool rock. I liked it. It did not react with HCl. It's kind of obvious. It doesn't have calcium in it. But yeah, that's olivine.